By 2026, the open weights landscape abandoned the race for conversational chat quality. The metric for success shifted entirely to reliable tool use and autonomous software engineering. IBM engineered the Granite 4.2 release specifically to address this enterprise demand for reliable, local execution agents. This datasheet outlines the family specifications: 3 dense models at 3 billion, 8 billion, and 30 billion parameters, all released under a fully permissive Apache 2.0 license. Previous Granite generations were instruction-tuned. The 4.2 architecture is built entirely around native reasoning, generating a calculated chain of thought before it emits an answer. Granite 4.2 secures high agentic benchmark scores without relying on massive, memory-heavy mixture of experts routing. Instead, IBM forces a dense architecture through a rigorous, multi-stage reinforcement learning pipeline, driven entirely inside active terminal sandboxes. Placing an adjustable reasoning widget directly inside an open weights release alters exactly how developers architect their local AI inference. Underneath the reasoning capabilities is a dense, decoder-only transformer, pre-trained from scratch on roughly 15 trillion tokens. This structural breakdown illustrates the specific internal mechanics maintaining context stability. It utilizes grouped query attention with 8 kV heads, Swiglu MLPs, and rope position embeddings with a high theta value to track dense information over long sequences. If you look at this timeline scale, you can see a deliberate split in the context handling. During Phase 5 of pre-training, the window extends to 512,000 tokens. However, the official published limit for active serving is strictly capped at 131,072 tokens to ensure memory reliability in production. That commitment to memory reliability scales all the way down to the 3 billion parameter edge model. This mathematical breakdown calculates the exact hardware footprint for local deployment. Running the 3B model with a 4-bit quantization requires only 1.8 gigabytes of VRAM, making it fully operational on a standard consumer laptop. The 8 billion parameter model steps up the requirement, occupying roughly 16 gigabytes of VRAM at FP8 precision, which fits perfectly on a single modern GPU. The 30 billion parameter flagship requires distinct enterprise infrastructure, targeting local clusters equipped with A100 or H100 accelerators. IBM chose to stick with this predictable, dense architecture because mixture of experts models fragment VRAM. Enterprise teams require exact, unchanging hardware budgets before deploying models at scale. Granite 4.2 does not require complex prompt engineering or specific trigger words to map out a problem. The chain of thought process is native. This code snippet shows how developers access that reasoning directly within the chat template. The system exposes 2 toggles: enable thinking and low effort, giving the operator absolute control over compute expenditure. The standard thinking mode allocates the maximum possible compute budget. It forces the model to methodically map out complex steps, resolving logic dependencies before attempting difficult math or coding tasks. The low-effort mode applies a constrained, shortened reasoning budget, designed specifically for intermediate routine tasks, where deep logic mapping is a waste of processing power. And the non-thinking mode disables the internal logic mapping entirely. The model bypasses the chain of thought and streams an immediate, direct response. This side-by-side interface comparison demonstrates the latency trade-off. Heavy reasoning holds the user interface for several seconds to process logic, while the non-thinking mode matches the instant responsiveness of a traditional chatbot. Looking at this bar chart comparing the total energy cost, the non-thinking mode reduces output energy by 60% per interaction. For high-volume formatting or extraction tasks, this drastically lowers operation costs. The engineering trade-off is absolute. Bypassing the chain of thought causes the model to fail consistently on multivariable logic and complex mathematics. By building this switch directly into the open weights, developers can route traffic dynamically. They can optimize for logical depth on one request and UI responsiveness on the next, all without paying per-token fees to a closed API router. The behavior of the 8B and 30B models stems from a specific post-training curriculum. Instead of a standard single-pass reinforcement learning run, IBM designed a multi-stage, multi-environment pipeline. This flowchart maps out the exact training sequence. It begins with supervised fine-tuning across 7.2 million samples. 31.6% of this data is strictly agentic, and the vast majority of that slice is pure software engineering. The model then moves into a verifiable reward reinforcement learning phase, which permanently grafts foundational capabilities like science, math, and competitive coding into the weights. The critical turning point is the agentic block. Here, the model transitions away from generating text and learns to interact with distinct environments, training on terminal automation, web search, and software engineering. The curriculum concludes with a final alignment phase using human feedback. Each stage in this curriculum is trained using asynchronous GRPO. In this asynchronous setup, a pool of generation workers continuously samples trajectories into a shared buffer. Simultaneously, the trainer pulls from that buffer and takes optimizer steps without ever pausing the generators to wait. To maintain training stability during this continuous loop, IBM computes advantages using a leave-one-out baseline instead of a value network, and applies truncated importance sampling to prevent older, stale tokens from hijacking the update. During the agentic block, the model does not learn by reading static text files. The training occurs inside active, real-world terminal sandboxes. The system forces the model through multi-turn trajectories. It takes an action, reads a resulting error code from the sandbox, and writes a correction, sustaining this loop for up to 128 environment turns per rollout. This execution loop illustrates the model's autonomous workflow inside the terminal. It reasons through the prompt, calls a tool, observes the terminal's output, and formulates an answer based on the result. It emits these actions in the standard OpenAI function calling format. Because it speaks this exact schema natively, it drops straight into existing agentic harnesses without requiring custom adapter glue. This multi-stage, sandbox-driven pipeline is how Granite graduates from predicting the next word into an active software engineering agent. It becomes capable of driving a command line with complete autonomy. The impact of that training pipeline becomes obvious when mapping the benchmarks across the 3 parameter sizes. This data table illustrates performance on real GitHub issues via SWE-bench verified. The 30 billion parameter model reaches a score of 57.00, confirming its capacity to resolve complex, multi-file software engineering tickets. Notice the missing data for the 3 billion parameter model on both SWE-bench and Terminal Bench. Those scores are blank because the 3B model was intentionally excluded from the agentic RL block. A 3 billion parameter architecture simply lacks the structural headroom required to master long-horizon, multi-turn tool calling. While the 3B model excels at lightweight reasoning and summarization, the 8B model is the absolute minimum viable checkpoint for deploying an autonomous coding agent. In a market crowded with open weights models scaling past 100 billion parameters, Granite 4.2 targets a much narrower, specific deployment constraint. Massive frontier models will post higher absolute reasoning scores, but they are incredibly difficult to self-host. Granite targets the enterprise need for predictable, secure, local hardware execution. This network topology diagram maps out the production architecture. By serving the 30B flagship's FP8 weights on VLLM and layering on speculative decoding, organizations can match the per-token output speed of a closed cloud API while keeping all execution localized. Alongside the language models, IBM also released Granite Speech 5.0 Turbo CTC, a 470 million parameter edge model that handles real-time transcription, completing the local enterprise toolset for contact centers and high-volume audio processing. Keeping these specific models on-premise guarantees complete data sovereignty. Codebases, financial data, and logic workflows never leave the hardware. Granite 4.2 sits at the exact intersection of 3 specific requirements: a permissive Apache 2.0 license, a predictable, dense architecture, and native sandbox-trained tool execution. By combining those 3 traits, Granite 4.2 provides the infrastructure to build secure, predictable, and autonomous enterprise pipelines completely free from closed API dependencies.